everyone. Welcome to this episode of the BimTube podcast. My name is Stephen, and today I've got Greg Cocks with me. So welcome, Greg. Thanks for joining me.
Pleasure to be here today. Thank you for the invitation.
Great, thank you, and I look forward to talking to you. So, as with all my guests, it would be great if you don't mind introducing yourself. And then I think that what is really interesting to people that are particularly new to these topics and maybe feel that some of what we talk about is quite complex. My point is that everyone has a different journey, everyone from a different background. So if you could also just give a little overview of your background and how did you get to where you are today. So over to you, Greg.
Sure. I was born and raised in New Zealand. And then I left reasonably early. I was a ski bum for a couple of years, Whistler and Italy. So I enjoyed that. But then I realized I had to get a real job to pay the bills and to afford some nice stuff, I guess. Was fortunate enough to get my green card in the green card lottery. So now I'm a US citizen. My original training was in engineering geology. So I did a bunch of work in the outback of Australia in engineering geology. But when I moved to Seattle, when I got my green card, it was too rainy and too wet to actually go outside and do some tank yanks and play with soil. So that they said, "Oh, you know computers, don't you?" And I went, "I guess." Well, how about you start doing some GIS for us, spatial data management? And that's how I got into it. And since then, I've been working in spatial data management, but my focus has been applied science. I'm not a GIS tech per se. I guess my best phrase would be I'm a technical bridge. So I worked on nuclear site cleanup. So I was the person that took the information that was provided by the environmentalists and the technicians and so forth and tried to translate that into a way that the maps and the spatial analysis could be done. Same thing with a little bit of oil and gas, looking at places where gas pipelines ran through high consequence areas where there's a big town or something like that. So to me, data is about how you use it. It has no intrinsic value. My current role is I work for the USGS as a federal government employee, and I work in the area of hydrology, water, getting water data to the incredible multitude of end users that want to use water data, from agriculturalists to resource management, to feeding a city, to watering crops, as I mentioned, and also making sure that ecosystems stay in place. So that's getting that data to them and collecting it. And my current role, we're doing a new system where we take elevation-derived hydrography, consistent scientific data set, and then we are generating a large database, or will be a large database, probably have around 250 million flow lines in it. And then we're going to make that available to the public so they can do all the things they need to with water resources and things of that nature. So that's big data in the big sense. So that's about me.
Great. Thanks, great. You mentioned USGS. Now, you'll be very pleased to know, obviously, I know who you are, but can you just explain what that is? And also, obviously, you're focused on the hydrographic side, but their remit. So, for example, I used to work for some equivalent in the UK, which was the Department for Environment, and there is geology. Can you just explain their remit? Because I would suggest it's probably wider than the name might suggest.
Very much so. The USGS started out as back in the 1880s. We've been around for a long time. And by we, I mean the USGS. Stands for the United States Geological Survey. It's a branch of the federal government under the Department of the Interior. But it's not just about geology. It's about many things. It's about water. It's about resources, obviously, but not just geologic resources, also ecosystems. We do papers on flood management. We work with FEMA. And in a sense, we're kind of a pseudo university in a sense that we're the people that make the data. Then others take it, like FEMA might take it, or the Corps of Engineers might take it. So we build some of the baseline data sets for transportation, or work with others that do. And so our remit is, as you said, is quite broad. If it goes on a map in a sense, or if we can do spatial analysis with it. And we like to think of ourselves as cutting edge, and we are. The Landsat program is part of the USGS and some associates with NASA, taking pictures of the Earth, to be simplistic. And then that's used for remote sensing and so many different uses. As we all know, Earth observation is the coming trend, especially with multiple spectral analysis. And so we provide some of that data. And our remit is to be open data. Quite recently, we had the Geospatial Data Act, which Congress in the USA has handed down to us. So we are now providing, along with the proprietary formats that Esri uses, for instance, and they're good formats, don't get me wrong, we also have to provide GeoPackage. That's one of the packages that I looked into, and we now use that to distribute our data. So somebody at a university that doesn't have Esri software, or a small agency or a non-profit, kind of like an OpenStreetMap version in a sense of scientific data with a spatial focus.
Yeah, great, thank you. And we'll obviously come back to open data. So I know it's a big topic, and we can go, several places with that. But just if I just pause for a second, for the benefit of the audience, BimTube is obviously the title. I mean, better information management, not necessarily BIM as in 3D, but we're going to talk about digital data and wherever we go, right? And obviously, we both have a geospatial background, so that'll be a strong flavor for this episode. But I know one of the topics we were going to touch on, which maybe we'll just bring up immediately, is about sort of the resources in this area for young people, processes, technology, and expectation. So have you got anything to say about that, about what, sort of, I'm putting words in your mouth about the expectation, but how are things now and what do people expect?
You probably can't see me, but I have gray hair. I've been in the field a little while. When I was a kid, I wanted to get around. I would reach behind my driver's seat and I'd pull out the A to Z when I was in London or the equivalent in New Zealand. And I would look up an address and go to page 7 and A3. And you'd go and find the address that way. Then you'd look around maps. Now, young people, and I think this is a brilliant thing, they don't have to think about that. Intrinsically, they pull up their phone, Google Maps is there, and that's GIS, that's spatial data. They then use that and get to their mate's place or go to the grocery store. And then they get that spatial knowledge that we all learn eventually, that machine memory, as it were, muscle memory of how to get around the place. But Google Maps is their entry point. Also, too, in primary school in New Zealand or grade school if you're in America, children are using GIS, making maps, building things as part of their school projects. They have computers, and which is wonderful. They have access to computers. And so GIS is kind of becoming part of how people think about things, even if they don't necessarily think about it that way. If you watch the old TV show Mad Men back in the day, there used to be a thing called a typing pool. And all the executives would talk into a dictaphone, and then somebody would type it up, and the memo would be sent out, or the letter, or whatever else. No, but typing pools don't exist anymore. We do our own typing. We type up our own reports from the newest employee all the way to the top, mostly. And I think GIS is going the same way in the main, especially GIS desktop, because these people, the young professionals coming into the marketplace, have it as part of their background. I taught GIS at a university here for a little bit, and just to help the mate out. And we had people from everywhere, because GIS is not a field. It is a applied tool that people use to make better data for themselves, because all data is spatial, really, apart from pure mathematics. Most things have a spatial component, how it relates to other things in the world, and the data that goes with it. So I think that's that's the beauty of young people, and I'm kind of jealous in a way. We had to grind through that, but now we have all these tools, and it's really cool. And I'm excited to see what they get to do.
Yeah, no, I think like you say, maybe some of the tools were available at different times, but it's that barrier to entry, isn't it? Where it was, I remember, I'm probably not quite as old as I look, but I remember even loading a map in some of the earlier GISs it was complex. So there was a stage, and maybe we could just elaborate on the process side. I know you've given an example, but have you got any other examples of where processes or are now so more efficient and easier? For example, creating a map or whatever it is, a dashboard. Have you got any examples where the processes that you've seen it be a lot easier for people to get involved?
Well, here's an example. As I said, for the USGS, we share data. One of our mandates is to make data available for the public, because we're a taxpayer funded agency. Our example is part of our mandate is to make data available so people can go and use it. So back in the day, even a few years ago, you'd go to a website, download some data, you'd make sure the projection information is there, you'd open up your desktop GIS and you plunk it in there, and sometimes you have to adjust things and change the symbology or whatever else. Now, and I built one yesterday, or was part of building one yesterday, there's a service. So you go to the service and you throw it into your GIS desktop, or you throw it onto your cell phone, and you can download a copy if you need it. And then you can walk around. We're carrying little computers in our hands that have incredible mapping capabilities with inbuilt GPS and satellite and everything else. So now it becomes part of our workflow and intrinsically integrated, as it were. So we don't have that boffin sense of like we have to grab the stuff and poke at it and hit it with a screw, hit it with a hammer or something to make it work. It just it flows into our workflow and makes our applied science uses of spatial data so much easier.
Well, just one, and we're going to just move on to open data now. But I guess one of, I don't know if you've got any observation on this, but one of the, I guess, challenges, or one of the potential challenges about opening data is everyone gets it, which is a good thing, right? But then it might be that people don't necessarily know how to interpret it. Now, have you got anything to say about that? I'm not, it's great that people can get it, but there was always a procedure, professionals, have you got anything to say about that? Maybe people getting their hands on data, they're not too sure what to do with it or what it means.
Well, what we do here, and I'm using my examples, is that we manufacture or provide the data at various levels. If you're talking to your grandma and you're telling her she asks what you do for a living, you won't give her the details of JavaScript or some Python that you've written. You say it's like Google Maps, only cooler. But if you're talking to your boss, you'll give them a little more details. But if you're talking to the developer that knows more than you do about certain things, you have to give all the technical details. So and I think a lot of people are doing that now. OpenStreetMaps is a good example, where the data is focused and accessible for your use case. To use an example, the USGS makes these things called topo quads. The Ordnance Survey in the UK has a very similar thing. But if we have 250 million lines that are going to be in the latest 3D hydrographic data sets, that's going to be too many lines. So we're writing code right now to thin that data down to make it appropriate for a 1 to 24,000 map, or a 1 to 100,000, or whatever the map's going to be. So we're going to write automated processes to shrink that data down, so you don't have to go, well, is this line important? So we're focusing and targeting data sets for various triggers that people have. Am I using it to navigate? Am I using it to do some flood inundation modeling? And I think that those realizations, those flavors of the data are very important. If we give people so much data that their models can't run using flood inundation, their models are going to fall over and they're going to go somewhere else to get their data. So we have to focus and target our data to suit those approaches. And I think that's part of it, along with metadata, the thing that everybody needs but nobody wants to build, and documentation. And I think we actually have a whole team here called user engagement. And their user engagement team is to say, how do you work with things? What do you need us to do to make your data more accessible, make our data more accessible to you and more transparent, and as you say, more understandable? So documentation, they say, hey, can you add this to it so that we understand that the name there comes from somewhere else or whatever else. So however we approach it, we want to make sure that it's user engagement, because otherwise, what's the point?
It's interesting you mentioned that user engagement part. That often comes up in sort of my day job, where I'll talk about, well, I used to be, my original first job was as a cartographer before I got into GIS, sort of pure GIS. And guess, and again, just reflecting, this is obviously for the benefit of people listening or watching, not you. We knew what the map was going to be used for, right? That was our job. Yeah. Our job was to think all day in detail, very carefully, exactly what people were going to think when they looked at things. And I think exactly, and I think that's the point that you've just made. That's what people are starting to do more with curating data. The argument should be that people probably should have been doing it, but the example you gave of generalizing the lines, I think, is a clear one where or you have an idea of the use case. And that all feeds into the open data. I mean, other than that challenge around making the right product or service with the open data, have you got any other examples of what we might call like the power and pitfalls of open data? So more broadly, what are the challenges and what are the benefits?
Open data is wonderful, but open data doesn't have that business consistency sometimes. Let's say, using Esri products as an example, their data, their structure is built within a framework. They future-proof their data, or their applications, I should say. So they might build survey 1, 2, 3 and then they might build some ArcGIS enterprise to deliver the data. But in the background, somebody's going, oh, what's the tendrils that reach between Survey 123 and ArcGIS Enterprise? How do they connect? Whereas open data sometimes, and they do an amazing job, is some gentleman or lady over here is building the equivalent of Survey 123, and somebody else over here is building GeoServer. They don't necessarily think about the use cases and how those tendrils might come together as much, because there isn't that business use case. And I think that's one of the pitfalls of open data. And obviously there's the ones that people might move on, or they might win lottery and stop working on things. But at least for us, but the beauty, to flip it around, is we also have things like the Open Geospatial Consortium. So the project I'm working on now is hydrology in the USA. We're using OGC standards and models and core data models to drive our core data model. It's called HY features. So around the world, hundreds of hydrologists and spatial technology people have got together and said, what do we really need in our data model? HY features for OGC. And so we're leveraging that in a positive way and what's that old joke, good code is code and better code is steel. We are basically taking the information that they've developed through so many years and so many experiences and so many use cases, and we're going to leverage that, and we're building those HY features capabilities into our data sets. And so at the other end, there's a thing called the hydro infrastructure, the Internet of Water. And so basically what's happening there is we're going to be providing URIs and URLs persistent. So every flow line in the USA will have a URI and a URL to go with it. So if somebody goes and types that URI into GeoConnects, which is a Internet of Water application, it'll always go to that same piece of the river or the stream in the USA. And as the data gets changed in the back end, it will reflect that. But people can then code that into their software, and they can approach it that way. So that's the good side of open data, and open environments and open source, and that free information exchange. And being taxpayer funded, we need to think about those things. We need to give access and user engagement, like we said.
Yeah, thanks for that. That was I've tried to bring up concepts around linked data before on this podcast. It's not really gone. I haven't had the right audience. So you mentioned URIs, URLs, just as a slight diversion, because I've definitely got the right person to ask. Could you just explain what they are and just conceptually the benefits of them? Again, for the audience, it's not something we've discussed in detail as yet.
So a URI is a universal reference indicator, and a URL is we all know what a URL is. So what it is, it's a number that's persistent, or a characterization that's persistent. So whenever you go to that characterization or that persistent piece of information, you will expect to see something there. And so if, like as the example again, if you go to the URL for a stream, you will find details about that stream, whether you go there now or in 5 years' time, assuming the systems don't change. And the strength of that is that there is no assumptions made. Well, the assumption that's made is that that's going to be consistent, so anybody can build everything off it. Within the USGS, we have a thing called the DMCCP, the Data Management Change Control Procedure. And it sounds like it is a big long acronym, but when we start building things, the minute we touch something after we've released it, we have to think about, if we change the number of characters in a field, for instance, what will that break in everybody along the way? So we have to think about how this data is being used and how it's being connected. Again, part of user engagement. And I think the beauty of having URIs and URLs, these persistent identifiers that everybody can go to again and again and again, is that that's a way of getting not around it, but hoping to manage that sorts of necessary changes as technology comes along.
Yeah, and thank you for giving that overview. And you say everyone will know what URL is. You'd be surprised. I think not many people that don't work in IT would be able to tell you what it means. Yeah, they probably know it's a link, but I don't know. You'd be surprised after write reports and have to take out any IT jargon. But yeah, so thank you for that. On a serious note, that's really, and I think, but it does come with that perspective, doesn't it? The data governance framework that you've talked about.
Governance is a wonderful word.
that procedure is the governance overview, the rules that you were just talking about there.
Yeah.
And then on a solution, you've got a data model that you've been describing, and a data framework, and a solution architecture and enterprise architecture. I think these are all sort of more traditional IT domains that I don't really, amazingly, people don't talk about them too much. It's quite interesting. Do you find that in other domains? I don't know how much you cross over with private sector rather. Do you hear other people talking about these kind of domains? Because I don't enough. It's it's not good.
I agree with you, and I think the beauty of a federal government or a government agency is that we have the flexibility to not set the standards, because that's not our job. Our job is to help work with people to set the standards. But we have the funding maybe, and the mandate almost, the inclination as well, to look at those bigger picture things of how things integrate. Because I'm trying to think of an example. We gather a lot of data and we use contractors to get it. But the contractors have to have a business advantage, because that's how capitalism works, and there's nothing wrong with capitalism. So we say we don't tell the contractors how to do their job. We say, we would like the data back in this way, please. To meet these standards, it's going to have to meet these validation standards. So the contractor can then go along and build their own secret source that gives them a business advantage, be it AI, be it some code, be it however they want to approach things. They might have some amazing boffins, some scientists there that can say, let's process it this way. And then they give us back the data, and the data meets our needs as the federal government. And if I'm talking out of turn for the federal government, I do apologize. But the beauty is that the contractor then gets to have that advantage, and they can do their job better, faster, stronger, and we get better data, and so the price comes down. Does that make sense? So providing that framework of how we want our data and letting people attend to that the way they think is best, I think is an example of that framework that you're talking about. But yes, I think people work in isolation a lot of the time because they're the same. That's the way they've always done it. I've worked on a project, nuclear site cleanup, and the people have been working there for many years and have incredible knowledge in their head. And so I tried to bring in a data information management system for them to basically put it all in one place, so the guy sitting 3 cubes over or 2 offices over could see what the person next door to them is building. Now, we're not going to do it that way. We've always done it this way, and it works for us. So there's a resistance to that because people are comfortable with the way they do things, and trying to put a framework umbrella around it sometimes can be culturally difficult, private and public sector, and also, to be honest, universities as well, because people have a particular focus. That's how universities run. So it's hard, and you can't push a workflow on them. You have to say, how about this? This might be helpful for you. And you can show it to them, and they go, oh, that's really cool. Can you make it do that? And the minute they say, can you make it do that? You've hooked them. And then you can kind of show them, it's almost proselytizing in a way. You're showing them what the strength of what you're suggesting to them. Or you build them something and you build them what they request, but then you add a couple of extra things and they're like, oh, what's this? And then they're engaged. They see the power and the strength of it. So culture is a really important part of data management, how to build those structures and how to put those overarching things in. And companies like Google do it really well.
Sorry, Greg, I talked over there. I agree. Google do it well, and it's a focus of their business. I think it often comes down, which is what you're articulating there. It simply comes down to focus. I think sometimes, doesn't it? What's important to people? It's probably not managing data a lot of the time, even though it should be. I mean, generally. Do you agree with that? Again, maybe not in your organization, but generally.
No, it's everybody's organization, regardless of the sector, because people are under pressure to meet budgets, to get results out. When their boss or their manager or the project lead says, we need this, they can't, often they don't feel they have the cultural nonce or even ability to say, no, we've got to stop. We can't just do this. We have to think about why we're doing this. And to circle back, metadata is a perfect example. Everybody wants metadata. Nobody wants to build it because it's tedious, frankly. Apologies to all the metadata people out there. It's not the most exciting field in the world, but it is incredibly useful. It's like the same person back in the day who used to compile a phone book. That must have been before computers, or that must have been a horrendous job, but everybody used a phone book and wanted to use it. It had wonderful logistical needs, you know. So metadata is the example.
I think metadata is great, and you've talked it up. I mean, we're sort of naturally touching on it anyway. That's very close to my heart, especially with obviously a GIS background. But I would say that's one of the few domains, whether it's GIS or geospatial wider, that actually talk about metadata. You know, as know what it means. The other, in more sort of publicly, would be defense, and probably in ways that we don't want to talk about metadata. I've only heard it in the mainstream, in IT, in information management, in geospatial. So I think, you know, it's really not mature even in broader circles, surprisingly.
I think we think about it and do it a lot. Wikipedia is basically metadata, if you think about it. It's basically somebody's come along and collected all the information about a particular field, or one episode of Star Trek: The Next Generation, and put it on a wiki page. That's kind of metadata, isn't it? It may not be structured that way, but it's somebody's all the nerds and the geeks, and I use those as positive terms, have collected that information and put it on a wiki page, and it's there for everybody to use and everybody to adjust and everybody to reference. So it's not metadata per se, but it's characterization.
Greg, I completely agree with you. DBpedia, I would say, is the metadata substructure, but I completely agree. And I think, where is my Wikipedia? This is just hypothetical now. Often I work in large, I don't know, like rail infrastructure at a national level.
Sure.
I'll say, where is my Wikipedia or DBpedia for the assets, you know, for that bridge? And they don't exist. So I completely agree with you. Wikipedia and DBpedia under it is that. But, you know, when you go in an organization, you know, why can't I find out everything about this this bridge or this asset or this tree? And I think, again, getting back to the point with geospatial, I think that's where geospatial, or where things are, can be the way in for a lot of people. It's just instinctive. So often I'll play some kind of game of GIS or geospatial by stealth, you know. I don't know if you've got any examples of that. I mean, you sort of were alluding to one just before about sort of not laying it on the table and saying it directly, but let people find their own way. Have you got any other examples of how you sort of warm people up?
One of my previous lives, I worked on nuclear power plants, and we were looking at the infrastructure, and I mean infrastructure on nuclear power plants. And back in the day, there would be a big stack of blueprints, and the guy that's been there, or the girl that's been there for 30 years, would know exactly which pile of blueprints to look at. But they knew where the pipe came out of a building, and when it went to the next building, that pipe might be carrying some pretty lethal stuff, or some stuff that wouldn't want to be spilled. But nobody really knew where that pipe went underground, because nuclear power plants, they build a piece here, some new technologies came along. And so our role in the structural engineering company was to find where that pipe went. Or in a plant room, there was pipes going everywhere. Which one's that for? You know, nobody really knew where it was, which one was which. So we built 3D models of these pipes, so that if something bad happened or a pipe needed to be maintained, and if a pipe's carrying more caustic materials, the pipe should be checked more often. Oil and gas is the same example. If the gas if it's sitting in a low point, will collect water, and that might rust the pipe, and then it might go bang next to a church full of 100 people at service. That's not a good thing. And so having to find these high consequence areas is really important. And so these use cases, GIS has no intrinsic value. Spatial data has no intrinsic value. It's what you do with it. We can collect it all day long. I did some paleontology back in the day. Paleontology is not really that useful, but it's really cool when you get it in terms of biology and how biology flows into medicine and everything else, along with the academic components as well. So it's what you do with it. And so I think explaining why you use something and how you can use something, and kind of leading them down that path to be like, oh, you want to know about this? And you go up and you can pull up on your screen, and you can pull up a OpenStreetMap and say, hey, here's the latest whatever else. Or you pull up a IsRay map, for instance, or whatever, and they can see, oh, I didn't realize that my neighbor had put a swimming pool in their backyard. That's a facetious example, obviously, but seeing how they get into the data and kind of leading them down that path. I have friends that would like to look at GIS data, so I give them a couple of courses. There's another gentleman in the UK that has a whole bunch of videos on using QGIS, the open source desktop solution. You can go and download it, but when you look at it, it's like there's buttons everywhere. But you can go and lead people into it and say, hey, why don't you throw some OpenStreetMap data on there? and they can start using their own Google in a way, and they can start building their own things. They might use it for their homeowners association meeting to see whatever else. And I think that's the way we lead people into it. And that's why circling back earlier, the kids do this intrinsically as part of their coursework now at school and university. And they have that ability to just think like that. It's almost like a muscle memory. It's a tool that they already know about. They don't have to go, oh, is that GIS? Well, I'm going to give that to the guy in the corner or the girl in the corner.
Yeah, you're right. It's the familiarity, isn't it? I mean, it certainly. I mean, I don't know how long iPhones have been around, but not that long, right? I mean, there isn't a project to introduce iPhone apps anymore. You know, it's what do you do with it? You know that. Only literally a few years ago, that would have been a challenge to say, oh, no, we need to introduce smartphones and there'll be pushback and the change management. So I completely get where you're coming from. That change management side of introducing new technology can be a real challenge. And if that barrier isn't there, as in the example that you're talking about, I often think, I don't know if you've got anything, just thinking aloud here, I often think, sometimes in my mind, things are devalued. Maybe that's the wrong word. So, for example, obviously we can have maps on a phone. We've given that example. And even if it's part of a suite that we might have corporately, for example, part of the ArcGIS Enterprise suite, because they're included or free in inverted commas, sometimes people don't think, lose the power, the value of that, having that app on the phone. Do you see what I mean? But maybe 15 years ago, it would have been a $250,000 project for me to give everyone a map on their phone. Now it's just there. Do you see what I mean? It's almost like it's devalued. I don't know if you've got anything to say about that, if you thought about that. Do you know what I mean? I guess where I'm going on a broader picture is if we give data for free, I'm just thinking, continuing the thought here. If we give things for free or near free, or they're just sort of there, maybe they're not utilized in the way that they should be all the time. Have you got any thoughts on that?
I think that's undervaluing people's ability. And the best way to see that is if somebody's out hiking or tramping, walking, whatever, and they lose cell phone connection and they don't have a paper map with them, they freak out because they don't know where they are. There might be a open ordnance survey scan up on the moors of somewhere over in Scotland, and they go, oh, that might be. I'm going to walk towards that because that looks like something. But it's the absence of something that I think shows people the power of something, and I think that people recognize things in their absence when they don't have it, their internet connection, whatever else. But I think the fact that people are using Google Maps and using this data that's free or readily available, and again, free in inverted commas, like you said, I think that it's become part of their lifestyle and the way they approach things. And I don't think it undervalues. I think it actually values it more personally, because they get to use it and don't think about using it. I have an old '68 Land Rover. I like climbing under the hood and messing with it. It's fun, but I get in my more modern car or my modern motorcycle, and I don't care how the engine works because I could never understand it because it's got so complicated. But then I realize I don't have to understand it because it gets me to work and I get to play on the weekends on my motorcycles and blah, 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 because it just does what it's supposed to do. And we rely on so many people in our lives and so much technology in our lives that we don't need to understand it or even fully comprehend its value. Again, until we don't have it absent. You go to a third world country, say, or a less developed country, and that medical's not quite available, then you realize, I do need to have that my X-ray, and there's no X-rays around. Maybe that's a strange example, but I think it becomes part of who we are and how we approach life.
Yeah, great, thank you. Yeah, like so I was just thinking aloud about the comparing things, particularly across different nations as well. So the richness of data that we've already talked about that you have through USGS, and obviously there's federal funding. You think that's not the case. Some people have to make that business case in a business context as well. I mean, someone might say, can I get satellite imagery or something for a business function? And the response might be, well, what's the value in that? And they, I don't know. Do you know what I mean? They don't know where to start.
The European Space Agency and NASA too, with their Landsat, makes this data available. So I was reading a paper the other day about they were using Landsat and Earth observation data in Africa for water resources because the climate change and extreme weather, and they were looking at groundwater And they were actually using Earth observation data to look at the ground surface to see how much groundwater could be underneath it with some extrapolation and everything else. But they weren't using proprietary data. They were using regular data. They're like the boffins that just sit in a chair and they just think about things. And then they say, hey, okay, go off, and they have a technician that goes off and do, or they do it themselves. They have access to their resources in ways that we don't understand because we don't live in those countries. Not as much, obviously. They don't have Google Maps and OpenStreetMap. But even OpenStreetMap, there's one gentleman in South Africa, I think, that's put in 120,000 lines. That's because that's his passion. That's his hobby, as it were. So I think it does exist, just in different ways and different approaches.
Yeah, and fit for purpose, of course, is the
exactly.
You can always go. In fact, the irony is just closing the loop for me around the BIM, which is the construction and the 3D side. I often see over delivery now, which is sort of ironic. Sort of if there is such a thing, people laser scanning everything like there's no tomorrow, and yet they might be missing some fundamental data sets. So I think. Anyway, if we just move on to one of the other topics that we had, I know one that you'd mentioned there was about keeping yourself engaged and enthused about your work. Now, I think I can tell from yourself, and I'm certainly very passionate about these topics, hence why I've done a podcast. So I really love these things. But what have you got to say about keeping yourself engaged and enthused? Have you got advice for people? How do you do it?
Mm-hmm. I'm never going to be a millionaire because I don't have that mindset. And there's nothing wrong with millionaires. Billionaires may be a different story, but that's something else. But for me, I like the idea of my work I do, in small part, being useful to people. It sounds a little fluffy, maybe, but even 200 years ago, we didn't have access to medical. We didn't have access to heated water in the houses as readily as we do now. But along the way, somebody invented plumbing, and somebody invented electricity. And it wasn't somebody, it was a team invented electricity, if that makes sense. So as we go about our daily lives, I like the idea, and maybe I'm being a little strange, but I think it's important that what we do is helpful to people, at least for me. But the way I use my data, or the data I build, or how I think about it, it's applied science, it's applied technology. I would love the fact that somebody pulls up on their phone, hey, it's really raining hard, and I'm an agricultural worker or a farm owner in Kansas or somewhere else, Africa. Is it going to flood? So they can go and jump on their webpage and see, have a model run on their particular area, but they don't have to think about what they do. And somewhere along the way, maybe some of the data I contributed or we contributed, I should say, on flood mapping or water bodies or flow lines or the size of the stream or whatever else has played into that use case. And I'll never know about that. And the team I work with will never know about that exactly. But that one farmer in Kansas or in Africa has a better life and is able to handle their life better and their livelihood and looking after their families and everything else because of something we helped make happen. So that's my engagement with doing my job. The other part of my engagement, I think it's fun. I like seeing stuff, and I've been around long enough that I'm like not an old man or anything, get off my lawn, but I've been around long enough that back in the day when we had ArcMap 3.2, when you climbed inside a text file and you were changing some of the parameters, and now I wouldn't do that. But I have new technologies. I have my services, and I'm building these things and working with developers and delegating some work and saying, oh, I can write some Python, but my developer can write Python better than me. That integration of all of those ideas and being really engaged by what they do it's really kind of fun. And coming to work I try to make it fun. I have a good home life, don't get me wrong, and recreation and whatever else. But if you're not doing something that you like, what's the point? Unless you really need the money. Yeah.
Or both. I mean, it helps.
Yeah.
But yeah, thanks, Greg. I think having that sense of purpose is. I mean, you were lucky to have it, but also people need to seek it out. And just if I can just link to I said the word purpose, so it made me think. The United Nations Sustainable Development Goals. Now, obviously, in the department you work for, you'll know all about them. But is that something that commonly is talked about or reported on, or just a feeler? Because I hear them occasionally at conferences in the UK, but they're not persistent necessarily. Are they talked about a lot?
Well, we're in what's characterized as the Western world, so we have less exposure to them, and maybe because we've been lucky enough that we don't need to have that exposure to them. But in other places, I think the United Nations are doing incredible work, plus or minus, because there is a need. Droughts in Africa, health, endemic epidemiology, whatever else, childhood health, maternity care. These things that we take for granted, I think the United Nations is making other people get to take for granted as well. And so I don't particularly touch on it, but I know from people that I've worked with, and I'm doing some mentorships with a couple of people right now that are working ancillary, that having that ability to see that Earth observation data from ESA or from NASA, to be able to think about a university funded program to look at groundwater or whatever else, I think it's a bigger scope than we can either imagine. And I love the fact that it's kind of like the internet in a way. We don't know what goes on, and we never will, because every little piece is kind of interconnected in such wonderful ways. Not perfect, don't get me wrong. But to answer your question, I don't get a lot of exposure to United Nations programs, but I do see some of it. I have an interest in Nepal, for instance, and personally. And so I talk to my friends there, and they say that, oh, United Nations is coming in and helping us, not telling us, but helping us to do better crop management and rotations and so forth, based on the climate and the things they've been seeing from space. They're helping us to manage our crops better, is an example.
Great. Yeah, I thought I'd just add it there. Thank you, because with that global touch points that you've got, obviously it does come up. I mentioned it to a few people on the podcast, and it depends, but it's certainly becoming a focus. Let's put it that way, and I think that's a good thing in a way. It's even if people don't understand them fully, it's the bigger picture. I originally studied environmental biology, right? And then got into GIS. So there is a bigger picture. What makes me smirk and laugh at some of the conferences I go to, more about construction. They go, oh yeah, maybe we should think about the environment. And I'm thinking, yeah, maybe we should. I mean, are you seeing that now, where people have suddenly seen the light? I mean, you work in hydrography, so you've always been thinking of the bigger picture. Are you seeing some people see the light suddenly, that maybe the environment we should be thinking about?
Very much so. It's strange that you said that, but in a good way. I was just looking at a paper, another part of the USGS, the Cheapskate Bay. There's been a lot of extreme weather, a lot of flooding. And so they've actually done some analysis, and with your background as well, you might be interested. They looked at the economic value of flooding, which is a perverse thing to think about. But the Mississippi being an example, when the Corps engineers put all these berms and embankments and everything up, and engineering, fluvial engineering, we don't get the bottomlands flooded anymore. So the nutrients, the sedimentation that beautiful rich soil brings, the ground is becoming exhausted because there's not that regular flooding every year or 6 years or whatever else. So the USGS did a study in the Cheapskate Bay, I can't remember the name of the watershed, and they were looking at the cost of the floods, infrastructure, public health, public safety, stream bank erosion, versus what the flooding brings in terms of nutrients and sediments and sustaining the ecosystem, giving trees a nice flood of water, recharging the groundwater to some extent. These things that man has managed with the immediate term goals that have impacted the butterfly flapping his wings, the longer term goals and the longer term sustainability of the ecosystems that the floods don't do anymore. The Nile in Africa is another good example. They don't flood that much anymore, and some of the ground is becoming exhausted down there, along with the water not being available for the local users.
Yes, it's really interesting. I never thought I'd get to talk about fluvial sedimentation on a podcast. I'm very pleased to have you as a guest, because it's all coming back to me, but certainly not at a professional level like yourself. But it is that systems approach. I hear that a lot now, even in a very narrow context around digital twin, the digitalization of built and natural, but systems thinking. Have you got anything to add about that?
Well, digital twins, I don't know much about it, but I've been looking at it. I think one of the companies, I can't remember, I think it might have been, it doesn't matter. They just built a digital twin of the whole of the city of Shanghai. And so that all the roundabouts, all of the houses, not the houses per se, but all of the traffic infrastructure and all of the water and everything else. And another example is Vancouver Airport just built a digital twin of their whole airport. So when they have emergencies, or when they want to redesign something, or they want to do some maintenance, they can run the analogies on their digital twin to see the impacts. And because it's all connected out further out, you know, rather than somebody knowledgeable going, well, we can't shut down runway 6 because we have that regular flight that comes in Cathay Pacific from Singapore every week. It's actually built into a model, an integrated model. And it's all GIS, it's intrinsically spatial. But maybe the people using that data, maybe the maintenance workers don't really know or care that it's GIS. They just say, well, if they plug it in, assuming the black box works correctly, it gives them information. Does that make sense? So I think that digital twin model is a really good one. But like anything, it's cool and it's fun, but don't just do it because it's cool and it's fun. The metaverse is a good example. I mean, I don't particularly want to walk around with Mark Zuckerberg because to me, it has no use case that I would particularly like to use. Not to downplay, because he's an incredible entrepreneur and so forth. But I personally haven't seen a use case for that stuff. So cool for the sake of cool, or interesting, or flashy isn't for me that interesting.
Yeah, so I'm with you on that one. I don't impress easy. I think the challenge is we've probably seen not everything before, but we've probably seen enough. Let's put it that way. Do you see what I mean? It's like,
yeah.
I've seen lots of 3D models. So then when I see another 3D or layers, or you know, it's like, well, okay, but it's always that unseen information. Is that I really like. I keep going back to the thoughts that you've been talking about getting the story or the use case, and I think that's so critical, isn't it? That people should have scenarios. I think one of the challenges I've certainly seen in the UK, just beyond sort of geospatial and GIS, but just in the whole use of the digitalization of the built and natural environment generally, which might have BIM and digital twins. I haven't seen enough until recently, enough compelling use cases. You know, that's the problem.
Well, one example in the UK, and I've been reading about it, unfortunately, is a lot of the water companies releasing sewage a lot, both riverine as well as coastal. And so building models that say, if we release sewage here, what's going to be the impact on the ecosystems, on tourism? Building that digital twin, and I'm using that word very broadly, that phrase very broadly. We can't just release sewage. It might be a use case, but if the Thames Authority releases sewage and you lose 30% of your fish downstream of the flood barriers, blah, 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 we need to know about these things, these consequences running on. But to circle back to your idea of 3D modeling, back when I was doing a little bit of oil and gas, they would use point clouds, and they would build models of the wellheads and all of the infrastructure that brings that gas out of the ground. And I'll be honest, oil and gas have brought us away from using horses, and has brought us so many good things. We need to move on, but I still think oil and gas has a power. But anyway, circling back, they'd make a point cloud model of their wellheads, and that was like 10 years ago, but they didn't have any real use for it. Now they can use AI, and they can look at a structure that's in the point cloud and say, oh, that's a valve number 763 style that we have in our catalog. So they can actually start building a 3D model using vectors based on the point cloud, using AI to do that for them, rather than a technician sitting there, which is never going to happen. The example of the nuclear power plant, we could probably have done a scan of a plant room, and then use some AI to actually help us build, and then get towards almost finishing the plant room infrastructure 3D model, if that makes sense.
It makes perfect sense. You talked about laser scanning and point cloud modeling for the benefit of people listening, watching, and I think, yeah, I was actually amazed. I came back from Brazil doing some conservation work 2014-15. I came back and laser scanning was becoming more of a thing, and I couldn't believe that you couldn't do feature extraction. but it is in 2015. They were like, oh, it's not really there yet, and because I'd just been using aerial and satellite imagery for, you know, vegetation, you know, semi-classified on a pixel level, because you know all about this. I'm just describing for the benefit of people listening, and I couldn't believe it. And I think it's really interesting you mentioned AI, although I've been watching that and involved in some of it. I haven't really thought too much about retrospectively going back and extracting features. That example you gave is really interesting, because I'm always sort of the approach about sort of on the Goldilocks approach with gathering data. Just get not too much, not too little, just get enough. But you're making me think again now to say, well, actually, maybe we should laser scan stuff because AI is ramping up. You're making me reassess my thoughts now based on what you've just said.
Well, part of what I do, the USGS has a program called 3DEP. And what they do is they're basically doing LiDAR scans of the whole country at 1 meter resolution, which is a huge project. But Google and I think Microsoft now have taken copies of that data because it's open data, and they're storing it on their own servers because they realize that these terabytes of data is very useful. But what we're doing now, for example, is we're using, this is my day job, we're using that LiDAR scans of the country, and we're looking for channelization to see where the river flows. So we can look for where the water is based on the 3D LiDAR, and we can make a very consistent product that isn't cartographic based, that isn't based on somebody field checking going out there. We can scan the whole country, as it were, and build these models of where the water is based on the LiDAR data, because the resolution, the data density is that good. We can start looking for other things. We can, I think some of the departments of transportation here are using LiDAR scans to do maintenance on their bridges. They can actually look for when there's offsets or some, not so much rust, but they can see where there's cracks and things like that. I want to, if I might circle back real quick, I want to give one example. And Ukraine's been in the news. And I think, talking about technology. And so there's some really amazing military technologies that are being sent across to the Ukraine. But there's also a company in Australia that is building effectively cardboard aeroplanes with little RC models, engines in them, that can be controlled by a little RC controller to deliver ordnance to the front line using a cardboard airplane that has a wingspan of about 5 or 6 feet. Rather than using something crazy like the American military do, a Tomahawk missile or whatever else, and that they have their place, but they're using cardboard airplanes. So they saw a use case and they thought about, well, why should it be so complicated? And I think that flies back to any technology, including geospatial technology. If it doesn't have to be complicated, why make it complicated just to make it cool and fun and interesting? And it's really cool. I'm sure a pilot who's flying an F-18 around has a hell of a good time and is defending the country as well. But sometimes a little old Cessna that's just doing some reconnaissance can get as much value, if that makes sense.
It certainly does, and I think it's difficult for some. I know we've touched on this point already. It's maybe with technical people, it can be difficult to abstract the purpose or remove the purpose from the technology. And I know that's what you just said. I'm paraphrasing it, but because it's the technology which is a manifestation of what people think. But the technology moves on, like the example you just gave or other example. The technology is always going to change. There's always going to be a new way of doing things or a different way of doing things next. But that purpose, that intention, might change as well, but normally that's more persistent. Like, for example, the bridge inspection, I have a background in rail as it happens as well. So I think, bridges, we're always going to want to know the state of the bridges, physically inspecting them. The laws state that we have to do that. There's different ways of inspecting them. Now we can put sensors in them, so it keeps moving, doesn't it? It keeps moving on all the time.
Well, a lot of councils and local councils or municipalities here in the US, they actually run a scan every year over their city, and they use AI to look for illegal construction in backyards, for instance. And I know in France they were doing the same thing, because a lot of the rich people in France were building swimming pools, even though in areas of low droughts. And there was a big kerfuffle in France because they were like, oh, we don't care about the rules, we're going to build our own swimming pool. And so they were then finding the swimming pools and then charging them or making them, sometimes cases, take them out. And so AI, and then with a human check afterwards, is maybe some people see as intrusive, but I see it as a bigger picture of let's all think about everybody, not just ourselves.
Yeah, great, thank you. And I mean, the times flow by because I've only, as no pun intended, from what we've been talking about. But I know there was one other thing we're going to mention that you might have touched on, but maybe if you could just elaborate on a project that you're working on with regard to LiDAR and IfSAR or InSAR. You'll have to educate me what IfSAR and InSAR are, because I'm not sure. I know what LiDAR is, but if you could just tell me about that project and what you're doing with it, that'd be great.
Well, LiDAR is they fly an aircraft over a terrain, and they throw millions, if not billions, of lasers down, and it's not impactful. It's not gonna cook anybody. And then based on the return time, they can then look to see how long it took to return, and they basically get X, Y, and Z of a whole bunch of points. That's the point cloud, and then they can build a model, 1 meter or whatever else. IfSAR is for places like Alaska, and people don't realize, because of the Mercator projection, how truly large Alaska is, and mostly uninhabited. Well, not mostly uninhabited. People in Alaska would take issue with that, but it's not as inhabited as somewhere else. But there's no take that back. There is no resources to scan Alaska at LiDAR levels, apart from Anchorage or wherever else. So what they use is satellite-based technology, which uses radar. So it does effectively the same technologies in the sense of how it's processed, but they use radar from a satellite. So that's IfSAR, scanning infrared radar, something like that. As an aside, there is another technology out now where they're starting to use lasers and other technologies to actually identify things based on the spectrographic returns of something. So they can look at tree health, for instance. I know in New Zealand that the police force actually uses certain helicopters to look for marijuana, because marijuana is still illegal in New Zealand that people grow in the bush, because marijuana has a very specific infrared return. So they can actually find marijuana, for instance. So what that LiDAR data does, and the IfSAR data, as I said, it builds this 3D model of the ground that becomes open data through the 3DEP program at the USGS. And as I said, Microsoft and Google have taken copies of data because it is so very useful. And then people can do value added to it. They can look for landslides, for instance, in the Pacific Northwest. Because LiDAR can look through trees, they can see landslides that were previously covered in vegetation. The Puget Sound LiDAR Consortium, which I worked with back in the day, when they first came out LiDAR, they were like, oh my goodness, we didn't realize how many landslides and slumps and debris flows and erosion there is, because it was all covered in all, you've seen the Pacific Northwest, it's all covered in trees and shrubs and poison ivy and whatever else. It's a beautiful technology that can see through the trees and get a picture of your ground.
Great, thank you. Thanks for that. And what I'll do is I'll obviously give links to anything we've mentioned, and particularly to these technologies if people want. But just as we wrap up, I mean, we have had our time, believe it or not. That was an hour.
It's a pleasure.
I know I could keep going, but I need to keep these to an hour. I wondered if there were any online resources that I'm sure you've got tens of them, but just maybe a few that you recommend people could look up some of the topics that we've been talking about more.
And I'm platform agnostic, software agnostic. Esri, the software company in Redlands, California, has some wonderful free resources online, sort of like Google, but more accessible, so you can start looking at your own environment. If you want to start getting into GIS on the desktop level, QGIS has a downloadable product that you can get, and it's free. And it's very powerful. In some ways, it's more powerful than some of the Esri stuff because it's open source, so there's more other things coming in. And explore it a little bit or explore it a lot. And don't be overwhelmed by the interface. Just start messing around and start adding things. And I'm sorry I've forgotten his name, but there's a gentleman in the UK that has a wonderful bunch of videos. If you look on my LinkedIn page, there's a link to it. And there's all these free videos that he said, how to add some data, how to do an analysis of a route or something like that. That's one resource that's wonderful. And start looking. The Ordnance Survey in the UK has a bunch of maps you can download in digital form. The USGS, you can download a whole bunch of maps. We have a new product called Topo Builder. So if you're in the US, you can actually go to an area and say, build me a map in this area, a topo map, like a topographic map. So have a look around and you'll be surprised how much spatial data is available for you at your various use cases. And as always, if you don't know or can't find something, obviously Google's your friend, but start reaching out to people on LinkedIn or through your government agencies, because people want to help. We do this for a reason, and we're happy engaged, most of us.
Yeah, great, thank you. And I can vouch for that because I actually, with a completely different hat on, and nothing to do with you, Greg, as far as I'm aware, I emailed the USGS some months ago now about some other type of data set, and they got back to me. I was, as an end user, I was in, and I can't remember what it was. I think it was height data for something I was doing, and yep, somebody got back to me and said, "Here you go, here's a link." So yeah, I can contest that. Yeah, very helpful indeed. So thanks so much. There's so much we could talk about. I'm really grateful for you spending the time with us today and sharing insights. So thanks so much, Greg Cocks.
It's been an extreme pleasure. So thank you.
Great. Thank you.